Yeah, I'm Leigh Capili. As Maz said, I do work with VMware Tanzu right now. We were acquired by Broadcom recently, so that's it's pretty cool to be working on platform as a service specifically now, and kind of our infrastructure stuff has been split out into a separate business unit. That's kind of fun. I grew up here, so I'm from LA. I live in Colorado now, and I love to snowboard. Are there any Filipino-American people in the room? I'm proudly Filipino-American. Hey, I love coming back to LA, hang out with my Filipino people, and go and find some sago later to have some dessert. You might have seen me around a little bit in the Flux project, and then I also used to contribute quite a lot to Kubernetes upstream, especially in cluster lifecycle with kubeadm. Recently, I'm back to contributing upstream. I'm working on some things that are adjacent to Gateway, this thing called reference grant that we can talk about later if you like. But yeah, that is a real picture of my dog. It's not a stock photo. His name is Pepsi, and he's a very good boy. So today's conversation is about Gateway API. I got really excited about the chance to dig in to Gateway, because every time I've used Kubernetes at significant scale, it's not been with Gateway, because Gateway is pretty new. And I think if there's probably some pretty senior practitioners here, there's a pretty good chance that you're not using Gateway right now, if I had to guess. Because Ingress is perfectly sufficient at the moment. It's probably running production workloads in your environment. There's a million examples. It's a very simple API, and it's really easy to get going with Ingress. You don't have to do anything special. It's like already there in the cluster. And so in order to get into Gateway, there's an investment. There's an investment in knowledge. You got to go and learn the thing. And then you've got to do some extra work as well to get everything working. It's built out of tree. And so beyond the basics, we get into some fun kind of nuancey situations. And then we're going to talk a little bit about a real world topic later that is still very much my crusade, very close to my heart. It's zero downtime deployments. A bit of a mixture of intermediate and beginner content today. Thanks so much for coming. So we have this fancy distributed computer that a lot of us community members have been working on over the past decade. If you haven't heard of it, it's called Kubernetes. And the cool thing about Kubernetes is it's got this declarative programming model. The declarative programming model means that you program the distributed computer in a way that maybe you're not so used to, right? And that seems like maybe kind of a basic primer since we've already been talking about Kubernetes all day. But why this is exciting when we talk about network technology is if you think back just like maybe a decade ago, there was a good chance that if you've ever been a network engineer, you're probably at a terminal in some co-located data center where you've got like a bunch of loud fans around you and you're hopefully wearing earplugs, and you're on that terminal logging into the switch because you got paged, and it's 11:30 at night when you'd rather be maybe like hanging out at home. And you're on that terminal and you are typing imperative commands to first build your mental model of the routing stack, and then try to figure out how to mutate the routing stack so that you can get stuff to go the right places. There's a lot of like fancy hardware that you can install physically, and telling that hardware what to do has not always been easy. You usually need a specialist to get in there. So what's exciting is we build this distributed computer, and the API machinery being so extensible in Kubernetes opens us up to this cloud-native world where we can all become basic network engineers. It sounds fun, right? I'm stoked about it. Yeah, I can tell everyone is stoked about becoming a network engineer. So the basic unit of compute in Kubernetes is the pod, right? And just a rough run through on the networking model and why all of this fancy machinery that we're going to be working up to is even necessary, is that pods come and go as they please. We have a lot of them over the life cycle of running interesting workloads on Kubernetes. And they all have individual IP addresses. And so we created the networking API. And there's an immediate split here. That's like an important theme. Compute is separate from networking in Kubernetes. So we make these things called services. And services have a controller that aggregates endpoints. And so it looks at all of the pods of like a particular label using a label selector, finds their IP addresses and collects them into an endpoint slice. We got a bunch of these endpoint slices. We also mirror it to the endpoints API so you can keep using that thing, which is old and technically not supposed to be used anymore. This slide is technically wrong. And now that we have these endpoint lists, we can keep them dynamically updated, right? And so we're always just watching, and then we do our best to keep that list up to date. And then there are a bunch of things from the ecosystem, from the core Kubernetes cluster, maybe from your data center, from some random bash script that you might be running in a CI job, that might be interested in all of that networking information. And traditionally, it has just been nodes, maybe a cloud provider load balancer, which is like a type of service. You just decorate your service to be a load balancer, and now it goes and does fancy controller things in your cloud that you pay a lot of money for. And then you've got the Ingress controllers. So Ingress was kind of the first community effort to extend Kubernetes in a way where we brought kind of the first application-facing protocol abstraction into the Kubernetes API. So we're beyond actually compute, and we're beyond networking, and we're into the protocol layer, which I guess is part of, it's a higher level networking layer, right? And so what did the Ingress API look like? Well, if we hop over to VS Code over here, and let's just pull up a rudimentary Ingress YAML. Okay, so here we have the networking API. We named it Nginx. This is defaulting into the default namespace, which is a terrible API decision that we all regret. And then now we have a specification. At the top level of the spec, we are going to have a list of rules. Those rules then can have these kind of protocol entries, and then within those protocol entries, you can go into paths, and then you can decide if that path is going to match on some particular conditions, right? So this one is a prefix match on the root slash, and that path, when it matches, is going to go to a backend. So, you know, if I wanted to be all fancy and stuff, right, I could like make 3 of these, you know, and then start sending them different places, right? Like maybe this one is the Nginx for the store, you know, and then maybe this one is the Nginx for, you know, the app layer, right? And then, you know, we can like change port numbers or whatever. And then we would maybe say this is the, you know, API v2, you know, and then this would be the store cart endpoints or something like that, right? And so what you're getting here is something that looks awfully like a reverse proxy configuration. And that's exactly what the Ingress API is for. It is a reverse proxy. That is the old term, and now we call it Ingress and gateway, because that's the cloud native like jargon. This is a reverse proxy config. We have a single listener somewhere that's then being multiplexed based off of the content of the packets that are flowing at the protocol layer. The reverse proxy is responsible for watching those packets, consulting its configuration, and then deciding where to send those packets and how to modify them based off of the config. And so we're kind of fanning out into multiple services. And you can make a bunch of these, so that's kind of fun. We start to get into a couple of problems here. And to illustrate problem number 1, I'm going to go to the Kubernetes documentation, which is here. So this is like the first touch point of the Ingress resource in the Kubernetes docs. I'm kind of wondering, this is like upstream Kubernetes docs, and for some reason we've got an example here. I guess it's a good example, honestly, because this is how Ingress is always used in practice. You hardly ever see an Ingress resource that's not annotated with something. And these annotations in the Kubernetes API machinery are how we can start decorating resources to have additional metadata so that something that Kubernetes core doesn't control, like an Ingress controller that comes from the community, can get more data about the resource and what its declaration is supposed to be. It's basically an API definition outside of the API definition. Ingress is one of the few APIs where this really matters because there is an Ingress class resource, which maybe, sorry, I didn't pull up an example of this. Here it is, Ingress class. So there's Ingress and there's Ingress class. Interesting, right? And that's because Ingress was built as a specification that was intended to be implemented by a bunch of people. And if you look at the CNCF landscape, you can see that that intention ended up being very successful because we have a ton of Ingress controllers inside of the ecosystem. It's super exciting because they get to bring all of their features, and by the time you end up using an Ingress resource in the wild, this simple example of a single annotation frequently ends up being like 12 annotations that are being operated on by 2 or 3 controllers. Often it'll be like your Ingress controller and then like external DNS, and then maybe also a cert manager annotation in there to tell it like which issuer that it's supposed to be using, and like what domain name is supposed to be like being put out into Route 53 or whatever you've configured with external DNS. And so this is kind of problem numero uno. Sub-problem of that as well is because we invited a bunch of people to extend this thing, we realized, oh, this is a pretty decent core subset of reverse proxy features, but it wasn't enough. It's never enough for anybody. And so the path prefix matching needed to then like be broken out to support wildcards, and people started doing that in annotations. And then people wanted to start supporting sticky sessions, and they started doing that in annotations. And the annotations got so sophisticated. Let me pull up traffic for you. Traffic. Check this out. This is so fun. I have used this web page so many times in my life, more times than I would want to. Yeah, this is an annotation, but it's like structured. Like we've got router.entry points, router.middlewares. You can set the priority of what this ingress rule is going to be using. These are all annotations that are meant to be used on a Kubernetes ingress, and only traffic understands them. So then traffic rightfully got tired of this, and then they made their own custom resource. And Contour got tired of this, and they made their own custom resource. And so it was really clear that Ingress wasn't scaling for people. Also, there's something sort of insidious happening here. We're mixing a lot of concerns into one object. One of the nearest and dearest things to a developer's heart is that traffic would arrive at their application. And nobody knows better what path to send things on and what port something should show up on than hopefully the developer of the app. But a lot of devs, I know when I started as a software developer, I was not a network engineer. I did not know that SSL certs were actually supposed to be called TLS, which is a different hill to die on, right? I didn't know what a network CIDR was. I wasn't sure how to provision IP addresses in the public space. That seems like a rare skill still. There's a lot of like very special skill sets in order to actually do real networking out in the real world. That's why we specialize and we help each other out. And so it would actually be really nice if all of this stuff that we were putting up here could be owned by a different resource. And that is pretty much exactly what we did with Gateway. The third and last problem that I'm going to point out as I complain about this beautiful object that has literally revolutionized the networks of many enterprises is Ingress is lacking precision in one more place. And that is that when you install an Ingress controller in your own cluster, you often can pick where that reverse proxy lives, the actual infrastructure of it, you know. And so you could put that on an edge node in your data center. You can run it as a fleet of pods on your nodes and expose them via node ports. And you then hook that fleet of endpoints up to an Ingress class, and then people can select into it. And if you want more of those, then you can deploy more of them. You make more Ingress classes, and people can keep selecting into them. And so developers can be like, I want this route on the internal network, this route on the external network, this one on the CDN, you know, and get the benefits of all of the fancy arcane configurations as long as I keep passing the same set of annotations that people tell me to do so. But then you get into a cloud provider, and they were trying to provide these awesome products. Like, I was using a lot of GKE at the time, and I'll be pointing to a lot of GKE docs. Today I don't work for Google, but today I am, I guess. And the moment that you wanted to deploy a global load balancer, the GSLB, you created an Ingress resource, select into their default Ingress class, and now you're paying like $20 a month for that thing, and it's routing like one service in one namespace. Now, you were able to then go and make another one of those in another namespace, and now you're paying $40 a month. And there wasn't a really great way to divide tenants up across namespaces and reuse the same load balancer with Ingress. And so, especially with cloud providers, they ran into this, like, I have to have these one-to-one mappings of expensive infrastructure to the things that I'm routing to in the cluster. When you start to get into people with like very multi-service architectures, I don't want to say microservices, right? Like, it just wasn't very cost-friendly, and a lot of people ended up just rolling their own stacks of self-managed Ingress controllers just so that they could get the proper service mappings to their namespaces. It's the hierarchy of our organizations always wins. But cool. So thank you for listening to me rant about something that we, probably a lot of us use. There's some growing pains that we've all run into, and that is why we are now in the beta after several years of Gateway API. Let's go take a look. Hopefully some of you are already familiar with Gateway. If you've never touched Gateway, Ingress or Kubernetes, hopefully we can also present the info in a way here where we can all learn something. So just coming back to our little slides. The really fun thing with Gateway that we realized was that second pain point. The stacks of annotations were building up. People were starting to have to build their own APIs. There's fragmentation happening in the ecosystem. And everybody had to use all of it, and it got all mixed up. And we had these single resources that were owned by multiple people, right? You had infrastructure people saying, hey, the Ingress class, points to this thing, so you need to know that. And then the ops folks were like, okay, we gotta make sure that we configure the proper wildcard redirects and header overrides and stuff in here. And then the devs were like, I'm trying to manage my paths and port numbers and like direct to my service names because I just added a new one. And it's all in the same object. That's not working well. So in Gateway, we really focused on 3 personas. Right? There's the person who provisions the infrastructure of the gateways. There's the person who operates the cluster, who decides how stuff gets divvied up, how stuff is configured at the networking layer. And then we've got to serve the application developers so that they can own their part of the config without having to worry about all of this stuff that they frankly shouldn't even have to like be concerned about knowing about, right? Like, I'm all for people learning new skill sets and stuff, but if somebody's not trying to be an infrastructure network person right now, they're just trying to solve business logic problems, like, let's let them do that and not tell them, you know, here's a 70-character long YAML string, you know, that you need to indent in the proper place in your service definition, right? So, gateway is multi-persona just by design, right? And you can see that if you go to gateway-api.sigs.k8s.io, you will see that right up front, right? Now, we get our first look at the Gateway API resource model. So not that many more objects. I mean, I guess you mostly had to worry about one before, and now there's like 7, technically. 8, there's 8. And so we got our classes, which is similar to Ingress class from before, new and improved. We have our gateways, which this is basically the replacement for the top part of Ingress, where all of those annotations went. Right? So now we can configure TLS certificates. We can do all kinds of fun, hacky, networky stuff to transform packets in the configuration of the gateway. And then we can hand off to our application developers who will say, hey, I've got a route on some protocol that I would like to expose. I want that to live somewhere in a namespace that I own, and please aggregate that up to some gateway. If I don't specify, please try to figure it out for me, or let me opt into some stuff. So that's cool. If you then hop into the Kubernetes docs here, we have a concepts page on Gateway API, where you can start to see how these things look. So with gateway classes, we have this example class, and then it ties into a controller name. So the way that the spec recommends that this works, because we can't force anybody to do anything, but we can say, hey, please be compliant with the way that it should work, is controllers will load up all of the gateway classes, filter them out, and then look for themselves in their classes so that the infrastructure provisioner of the cluster can decide which classes you need in a cluster. So if you want like a local load balancer class, and then a CDN load balancer class, and a public internet load balancer class, the infrastructure provisioner of that cluster can decide at that time. And then it can assign it to the gateway controller to go and do stuff. Yeah. Yeah, I think security is often owned by the cluster operator. I realize now that I haven't been speaking into the recording, so thank you so much for calling that out. I'm going to try to remember to hold this mic properly, and maybe I'll just take this off, because it's like muscle memory at this point. And, all right. Just there for now. Great. Thank you. Okay, so gateway class looks pretty similar to before. Now, I'm going to go and pick on GKE here because they've got some really good examples. Oh, actually, it was not GKE in my head. It was, I think, on this page. Yeah. Now, what's really improved about this is we've put a lot of effort into parameterizing the gateway class so that if you would like the infrastructure provisioner to be able to tell the gateway controllers how particular classes of gateways, anytime you instantiate them, should behave, you can add some configuration in the parameters references here. And this config can actually reference any sort of custom resource that you add to the cluster. So this is a great place for traffic to add a traffic config and contour to add a contour config because they can read their own schema and then decide how classes behave. So pretty awesome API decision here for the people who maintain these Ingress and gateway controllers. Gateway class gives you some ability to vary the configs. So that's kind of the first step. Now next, we'll just put that away. Next, on that chart, we were going from gateway class. Now we're going to make gateways that reference some gateway class. Every gateway has to be classified. This is the main tool that we use to help support multiple implementations of gateway controllers running in the same cluster, because now we can subdivide the API up amongst those controllers. And so with gateway, if we go to the API spec, you can see that, sorry, this was this example right here. So they start out pretty simple. This is the cluster operator now, saying, okay, my infrastructure provisioner has provided me some classes that I can select into, right? What would that look like in the real world here? If I go to the GKE documentation, this is why I was going here. There are a lot of gateway classes that you get from a Kubernetes provider's cluster. It's like the muscle memory is like not working with the one hand. I don't even know how to type anymore. Cool. All right, and I'm looking for internal gateway classes, and then I'm looking for this doc right here. Gateway class capabilities. This is a wonderful table. So they've got, I think, 8 gateway classes listed here that are potentially usable inside of a GKE cluster if you just spin one up. You're going to get a similar experience if you spin up a gateway-compatible cluster from some other infrastructure providers, such as Azure, or if you purchase something from one of the big vendors. And you can see that these gateway classes, some of them are multi-cluster classes, some of them are managed load balancers, others are various kinds of application-specific load balancers, and they all have some very interesting feature sets that you're able to configure with different policies that you reference inside of that parameter config. So all of this is done for you by default ahead of time. So I come into my GKE cluster, I just bought this thing. I'm like, okay, now I want to opt in to using some gateways. So I'm not paying for anything off the bat. But I have all of these configurations available to me. That's pretty cool. It's like I got a little catalog from the person who was provisioning my cluster. So I basically go and make my gateway, and then I select my class name. And then there's some kind of core fields here. It's listeners and addresses. And again, it starts out pretty simple. You can actually see in my demo repo, I'm going to be using something that basically looks exactly like this. But again, this is a great place for somebody to make some choices. And so when I actually make my gateway, yeah, I'm picking the ports, I'm picking the IP addresses that it's using. And if I kind of grep through for some examples here, right, this is kind gateway. And then, so here's a gateway class being picked here. You're still seeing some patterns of using some annotations to hook up to a structure that GKE knows about. But then, like here, we're using the address struct, and then it's using this named address, and that's actually going to use a name that means something magical to GKE. But look, it's an official part of the API. That's pretty cool. And then here as well is a static IP address example, right? So that would be the cluster operator experience of now provisioning some gateways that can then be used in the platform that I'm now implementing on the cluster that I just purchased. Very nice. So lastly, we've provisioned some actual reverse proxies. right? Like I have gone in, I've decided, hey, I want to use 3 of these gateway classes. I want something on my VPC. I want a kind of CDN capable gateway class to serve some assets, and then I also want a fancy multi-cluster, XDP powered, like nearest neighbor, nearest path routing kind of load balancer product. So I picked these 3 things. It's like my global load balancer, my CDN load balancer, and my VPC internal load balancer. So that I can talk to internal services. And I made these 3 gateways, and still nothing is being routed, right? So we've just set up all of the cluster infrastructure with the 2 personas. The 3rd persona is those application developers, right? So now we're actually getting to real business value almost, right? The only thing left for the app developer to do after they create these HTTP routes and TLS routes is actually do something valuable inside of the software that's running behind those routes. So that's like always the funnest challenge, right? And everything else is kind of just a slog, but we get to pretend to be network engineers. So the HTTP route resource is kind of it's going to be the most common one, I think, that a lot of people are going to be reaching for. And then TLS route is also going to be quite nice if you're looking for some MTLS kind of encryption in the cluster. So let's look at an HTTP route. I have an example of one of those. Not this. Let's go to our gateway example that we will be demoing in just a moment. So you can see I have a class here, and then I've provisioned the gateway. Unfortunately, I'm all 3 people in this example because we're a very small startup. So here's our HTTP route resource, right? So we're not doing encrypted HTTP in this case. I could have added TLS termination onto this gateway, but we skipped that for the moment. That's easier to do with a managed provider, of course. And this HTTP route, it looks kind of suspiciously a lot like Ingress, which is nice because people know how to use Ingress. There's plenty of examples. You probably have 50 YAML files of ingresses inside of your control repositories, and converting those is already a significant feat. So some stuff has changed here. We've changed some field names, and we've made things a little bit more capable. There are also a few deprecations, like prefix is no longer a proper word to use here. You have to say path prefix. You also will notice here that you can specify parent refs. So as a developer, if I leave this out, right, then it's kind of just up to the gateways to figure out if they should use my HTTP route or not. I could come up into the metadata section and I could start labeling my HTTP route, and then gateways that are using label selectors to filter down what they want to route can do that. You can also do it at the namespace level. You can also have multiple gateways reconciling the same sets or intersecting sets of HTTP routes, which is actually exciting because you might want your service to be reachable both on the CDN and from the internal VPC gateway. So you can see now that there's a lot of power here in separating the HTTP route and the gateway. Because now we can create one-to-one mappings, we can create many-to-one mappings, we can create many-to-many mappings, and do whatever level of sophistication is justified by our application's needs, or more likely the complexity of our interpersonal relationships in our growing organizations. So you'll see that this is kind of a protocol-specific one, and what's fun is if you hop over to the gateway reference, we don't have this here. We have it, where was that? I'm sorry I'm fumbling so much, friends. I'm like so much slower here. So here's an example of a gRPC route. All right. I'm not a person who's ever used the Google RPC. I've only ever interacted it when like talking directly to etcd, but I do know that there is a small but growing community of people who are trying to even serve gRPC to public endpoints and do fun stuff on it. Of course, inter-service communication is kind of the main goal of gRPC. And so we support gRPC route in Gateway, and you can still do the same sorts of things like rules, matches, filters, and you can send them to the particular gRPC backends. And then it is up to the Gateway controller to then support this optional resource that you can install in your cluster, and then know how to multiplex on gRPC. You know, needs its own stream processing and load balancing algorithms. Cool. We are doing pretty well on time here. Great. Well, this is a pretty high-level overview of the basic objects of Gateway API. Unfortunately, you can see that you already get into a lot of nuance with anything that's designed to be used by multiple implementers, right? And that is both the challenge and reward of going on a multi-year effort to ratify an API like this. Some gotchas are that as soon as you want to use Gateway API, if you have just spun up a core Kubernetes cluster, you're going to have to go install the API. So when you first spin up Kubernetes, Ingress is just sitting there and it's waiting for you. But Gateway is one of the first kind of very core intended, very official APIs that doesn't come pre-installed in Kubernetes and is not some feature flag that you can just turn on in the API server. It is actually shipped as a custom resource definition. The reality of using Kubernetes for anything real these days is you probably do need to install a custom resource definition. They're just shipped from the GitHub releases in this case. The custom resource definition is going to be separate from the gateway controller that you're going to install. So you're installing one thing from one place and then one thing from another place. That's kind of maybe a little bit of a mental switch. But they are often separate life cycles anyway. Installing a controller and installing the API the controller has to happen before that anyway. So let's get into a little discussion of some things that are developing. If you go to this API types, you can find this little button on the side here that will take you to this page called Reference Grant. Reference Grant is something that I'm really excited about right now. There is a problem that you run into when you want to start configuring infrastructure that needs encrypted or secret bits. Say we install a TLS certificate into a secret in our cluster. Now we have the ability to configure something to use the private key to serve some secure connections. We need to tell our gateway controller how to get to that certificate, and we need to give the gateway controller access to read that certificate. The sad state of affairs is that RBAC is technically good enough to solve that problem. But where we've ended up in the community is that most Ingress controllers that we install these days, and subsequently we add gateway support to these Ingress controllers, so now gateway controllers, it's basically become a canonical pattern that these reverse proxies that live on the very edge of your infrastructure have access to all and every type of secret thing inside of your cluster. And that's not great. It's a pretty big attack surface. These are the first point in which bits transfer into your network from a source that you can't control. An exploit in an Ingress controller could suddenly mean an exploit on all secret things that you keep inside of your cluster. And we should fix that. unfortunately, the path of telling everybody to do it a different way has kind of sailed. And so what we are trying to do is build mechanisms, build the fundamental mechanisms to start allowing APIs to have granular referential access. The source of reference grant is actually to try and do cross-namespace stuff. So here we have somebody who owns a service, and we want to make it possible for the person who owns that service to opt in to allowing the route to point to it from a different namespace. Now, you can see that this same concept would be useful for secrets, and it would be useful for any kind of backend configuration that needs to point across namespaces. It can also be useful for gateways and collecting routes, whether they should have access to those routes. And this API design is very desirable, not just to networking APIs. SIG Storage is looking at using reference grant. And then Flux, a project that's pretty far outside of Kubernetes core, has additional needs around cross namespace references. Typically, you see people making customizations or Helm releases. Sorry, struggling for that word. Releases that need to point to some source, right? So like a customization to a Git repository, a Helm release to a Helm OCI repository. And those sources could often be collected in some central namespace, but then you want to release them in namespaces that other people control. And so this is a very fascinating and developing area. And reference grant is already an optional component that you can install with Gateway, and some Gateway API controllers support it. And we currently just trust the Gateway API controller to follow the references and to properly implement the access controls. What we are working on now is a KEP for referential authorization, extending or maybe even being built into the core API server. And so this is really getting into nuanced, real-world, edgy stuff that doesn't work yet. We just have a barely working proof of concept prototype. This is KEP number, I think 3766 is the issue link. So that's probably the KEP number if I remember how that works properly. We've been working hard on this. It is collaboration between multiple people for a long time now. And we are speaking about it at KubeCon and are going to be trying to continue ratifying this API into something that is generally usable for multiple projects and can be authorized by the API server so that we can fix that problem of Ingress controllers having access to literally everything that's important. So that's just a little bit of nuance bits there. I'm going to take a step back here and go to a more lighthearted place, which is something that I think everybody can appreciate, a live demo. So if I hop over to here and let's see how this goes. I might need this. So right now, I have a kind cluster. It's, you can see it's just running core DNS, etcd, the normal kind CNI. We've got API server, controller manager, and the proxy scheduler. And then I've got a traffic controller. It says Ingress controller, but I'm not running this in Ingress mode. Ingress is not even enabled. It's purely configured for gateway. And then I'm not using this storage provisioner right now. So then if we take a look in our configuration directory, we can see I've got a deployment that's running my traffic controller. Maybe I could rename that to gateway. And then it's running just the latest version of traffic because I don't like updating the tag every time I have to do this demo. And then yeah, we can see I've disabled Ingress, I've disabled their special custom resource, and I'm enabling their experimental gateway support and then enabling the gateway provider. And then this container is just going to expose on the host port of this single control plane node that I'm running. And if we then look at the application that I'm using, I'm ironically using another web server / reverse proxy as my app. So it's just Nginx, a common little demo app for somebody who doesn't write too much customer-facing software anymore. This is just a deployment of Nginx. You can see I've got a bunch of replicas here, which will be useful. And then here's my rolling update strategy, which is pretty much default. I've got progress deadline seconds to 600, just labeling it with a version so I can constantly change out the pods when I change that version number. And yeah, termination grace period. So nothing else happening in the container spec. It's very just vanilla, latest version of Nginx. So if I look at the, oh, I'm sorry, I glossed over this. This is the CRDs for Gateway API. I am using an older version because my gateway controller of choice in this demo only supports Gateway from like 2 years ago. So, but it's good enough to display these concepts. So we've also got the RBAC. And then here is our gateway configuration. So we looked at this earlier. We declare a gateway class. We have to tell traffic, hey, my local gateway class, would you please control that? And then as the, so this is kind of infra provisioning. Now this gateway is available to be created as a class. And then I want to select into that class and make a gateway. If I wanted to, I could make multiple of these and try to put them on different port numbers. In my kind configuration, I have that port forwarded here. And then now we just are going to be creating a single HTTP route resource, right? So this is something that you could break out into your apps folder. You can make a bunch of these. You can do all kinds of rules matching here. You can put them in different namespaces, and you can select them into that traffic gateway, right? So the gateway is named traffic here, and then the parent ref here is traffic. The traffic gateway is of class local. Cool. Well, I've already applied this directory to the cluster. That's just kapply dash customize and then the folder name, which is Kate's. And you'll see that we can just curl localhost, and then that is the Nginx homepage, or default install. Cool. So what can we do with this? We can point out some problems with default Kubernetes behavior, which is always fun, because you would think that when you install a state-of-the-art distributed computer and you start using it the way that it's documented, that it would be like a good thing to do. Let's show that that's not the case. I'm going to start a siege. Siege is a command that just batters my web server with requests over and over and over again. So it's basically just doing that curl more times per second than I could with my own hands. And if I stop the siege, you'll see that we get some statistics here, right? So, you know, on a state-of-the-art little MacBook here, we should never fail a request, right? This is a very reasonable rate of requests to be serving. All right, let's go and try to do a rolling update, which is like the quintessential Kubernetes demo, right? Roll the credits. And then I need to, let's just get everything visible here. Okay, so I'm updating the label here. Thank you, Mas. Okay, apply -k. My Kubernetes, oh, what just happened there? That's not good, is it? That's a 502. What's happening, friends? That's not cool. So we talked about all this stuff. This is like the worst thing to show up in a user's browser, isn't it? Has this ever happened to you? Raise of hands. Yeah? Oh no, that's not fun. Yeah. Pod shutdown. So the Kube API server has a bunch of legitimate reasons to receive a delete from a controller. Like when you do a rolling update, you got to delete all the pods that were there before so you can replace them. Makes sense. The pod gets marked as terminating. Asynchronous consequence of that is the service controller has to remove the endpoint of the pod. Sounds good. Remember how like we try our best to keep the endpoints list updated? Of course, that takes some time. But the Kube API server is really good at getting that information to the kubelets quickly, right? And the kubelets, they're like, oh yeah, okay, like I'll just run any pre-stop hooks, and then I'll go ahead and send sigterm to PID1, and then maybe something reasonable will happen. It's not configurable, but hopefully your application does something good. It does something good maybe about half the time. And then termination grace period seconds starts, and if that termination grace period seconds ends and PID1 is still in the process table, then the kubelet will just be like, yoink, I'm going to kill that and rip it out of the kernel, please. And so that's kind of how pod shutdown works. The consequence of that is that most apps don't do the right thing when they receive a sigterm. Usually, you know, back in the old days when you like logged into the reverse proxy and manually edited the Nginx config, like you would open up the logs and you would check that the traffic drained before you killed the process. And that's usually not what happens. So you've got to do this thing called a pre-stop hook. Either that or you have to change the way your app is integrated so you can configure it. So the issue here is we've got an endpoints list. We've got a bunch of things in our network like gateway controllers and kube proxy and a bunch of, you know, maybe NF tables and then some BGP lists inside of your router and then there's like maybe some other controllers like the cloud provider load balancers who are trying to distribute all of the IP information about this pod, this thing right here. It's got an IP address. It's getting propagated to all of these places distributed everywhere around your network. There's no way you can know what the state of all of those things watching for this IP address are. And then we mark the pod as terminating. And kubelet wants to shut it down. And so it gets ripped out of the endpoints list. But nobody knows yet because they have to get that information. But meanwhile, we've already marked the pod as terminating. The kubelet has noticed. And now maybe this node has found out, but now the pod has shut down. It received a sigterm and then just immediately quit. And the gateway controllers and kube proxy and some router that's still like on that BGP advertisement, they're still getting that information to send packets your way. This is a really bad situation. That's where those 502s are coming from. Another creepy thing happens here actually, if I just do this one more time. I usually, oh no, rainbow wheel. What is happening? Okay, here we go. And then, if you like just let that sit there for like 25 seconds, like you notice we're hung. Like I can't even make any more requests, even though there are pods that are running available to serve requests. And it's because I'm waiting for a TCP timeout. And this will happen in a user's browser. And you really, really don't want that. It's a bad experience. If you wait a few more seconds, it just like, it kicks up again after the TCP timeouts actually time out. There you go, right? So people will be like, oh, I can fix this with probes. So I made this patch over here to just add probes, right? There's a liveness probe, a readiness probe in here. You got to be really careful with liveness probes. They're super dangerous, by the way. Make sure you just like really ramp these numbers up so they don't run that often, or just comment it out. But people are like, oh, this will fix it. It's not going to fix it, right? Readiness probe is going to prevent your application from receiving things when it's not ready yet, when it's starting up, or if it needs to temporarily close its doors. But when you're shutting down, this is not even looked at. People say, oh, you got to fail the readiness probes in order to make it start shutting down cleanly. That's not the case. It's not needed at all. I'm not going to show the demo because we're getting a little bit short on time here for this. But what I will show you is the way to fix it. In Kubernetes history, we've always had to do this patch. You might be familiar. It's the pre-stop exec command. And then you hope that this binary is in the container. And then you tune your network by doing some very sophisticated science, which is like watching logs and trying different numbers. And then that is how you make stuff work at a production-ready level. You will find this in every legitimate Kubernetes cluster that's running services. I have news. I've been complaining about this and not doing anything about it because it's hard and it requires changing the pod API for years. Tim Hawken opened an issue and then a bunch of volunteers got involved and they made an 81 file change to Kubernetes core and then documented it and released it in 129 as alpha. If you go to my kind config in this repo, I'm on the gateway branch, by the way, there is feature gates, pod life cycle, sleep action. You can turn this on. It's off by default. And then you can go to custom probes over here, and sorry, you got to go to the alpha folder. You can do this. It's beautiful. All of that work and years of complaining, and now you do not have to, you basically write the exact same thing, except this number is a real number, not a string. It's validated against termination grace period, and you don't have to rely on the existence of a binary. This is the best thing that's ever happened to the pod API. I'm so excited about it. Let me show you, it works. It is so good, all right? Let's deploy the alpha configuration there, get all those pods rolled out, we'll run a siege, and then we will go into the deployment, and then we will say, hello scale, 0 downtime. Okay, do this, let's roll it out. Look at that, like they're sleepy. The pods, they're so sleepy. They're just terminating there for a long time. And then they fall out of the endpoints list. And the gateway controller finds out about it. And it's just continuously sending traffic to the stuff that it should be. And then eventually these things just go away. Beautiful. I love it. Yeah. I got a story to tell you real quick before we wrap up here. Yeah. I was so tired. I could barely give my update at stand-up. Every app update had this intermittent state where the pods could barely stand up. Read O'Reilly and I was ready. Kubernetes looked so steady. Turns out I was overzealous because my merge request is sending every rollout I am checking. I'm seeing 503s. I'm digging every hole out till I heard this song from Leigh. See, this wrinkle seems simple when you muster up the principle. A multi-node cluster network cannot be invincible. And service and endpoint, the root of the point, is controllers need them slower because computers disjoint. I was tired, could barely give my update at stand-up. Every app update, the intermittent state where the pods could barely stand up. Hands up off the keyboard, I shipped a policy just to hook a simple 3-word pre-stop bin sleep. Now the users are hammering. I know I'm sleeping sound. The pods are stammering, but like kublets are sleeping now. See, this wrinkle seems simple. Muster up the principle. Multi-node cluster network cannot be invincible. Service and endpoint, the root of the point is controllers need them slower because computers disjoint. My Ingress controller, it comes with a gateway class. Then I made myself a gateway. Now I got myself a pass. So fast, deploy my apps. Check the graph, it's just as planned. Devs cramming one more YAML, so their traffic is just passed to their main route handle. Not needing any brandle, no stress. TLS, DNS, and no mess. HTTP, TCP, UDP to quadruple. Got a protocol tuple with that RPC from Google. Platform is simple, a gateway repo, infra ops dev in a persona trio. This is Leigh Cap with a recap. To the rhyme is how you know. This is Gateway API. Let's let the traffic flow. All right. So, thank you for listening to me rant. So.